Hello, good day! Ito nga pala ang inyong Sir Jello at mayroon ako ulit ituturo sa inyo na math video topics. Pero bago yan, huwag niyo munang kalimutang mag-subscribe sa aking YouTube channel na Sir Jello para maging updated kayo sa lahat ng videos na i-upload ko. Hello, good day! So, welcome again to another edition of Math Video Tutorials. For today, we're going to discuss about multiplication of radicals. So, there are three cases to be considered here. Number one, the indices are the same. Number two, the indices are different but radicals are the same. Number three, indices and radicands are different. So when we say indices, this is the nth root outside the radical sign. So for number one, indices are the same. So let us have the examples of each of these cases so that we can check the difference of these three cases. So number one, we have indices are the same. So when we multiply radicals having the same indices, we apply the law of radicals here. So you have the nth root of x times the nth root of y is equal to the nth root of xy. So here we have the same indices. So in short, we can directly multiply the radicand. So for number one, for example, we have the square root of 7 times the square root of 14. So we have square root of 90. Now we think of if it is possible, look at factors of 98 that has a perfect square number. So factors of 98. So in this case, you have 49 and 2. So 49 is a perfect square. So that would be square root of 49. So that's 7, then square root of 2. So that is the simplified answer for number 1. So whenever there is a radicand that is not perfect nth root or perfect square root, perfect cube root, so we think of two factors whose one of the factors is a perfect nth root number. So in this case, you have 49 as a perfect square number. So the final answer is 7 square root of 2. Next, number 2, we have a square root of 3 times b square root of 6. So there is a letter outside the radical sign and inside the radicand. So we can directly multiply a and b. So we can rewrite ab square root of 3 times 6. So that is 18. So in this case, we can think of factors of 18. One of the factors is a perfect square number. So for 18, so we have 9 and 2. So we rewrite here AB factors of 18. So that's 9 and 2. So square root of 9, of course, we have 3. So you just write 3AB, then rewrite square root of 2 inside the radical sign. So this is the final answer. 3ab square root of 2. Okay, next. For number 3, you have the square root of 2ab cubed times the square root of 12ab. So we can apply here the laws of radical and laws of exponent as well. No? So we just write the radical sign. So you just multiply directly. So that's 2 times 12. So that's 24. A times A, that is A squared. So we apply the laws of exponent here. B cubed times B is B raised to the 4th power. Okay. So we have 24. Since that is not a perfect square number, we can think of factors of 24, where one of the factors is a perfect square. But if we're going to look at A squared and B raised to the 4th power, since the index here is 2, we can write A squared B raised to the 4th outside the parentheses by simplifying this variable A squared and B raised to the 4th by dividing the exponent inside to the indices outside. So you have 2 divided by 2, so you only have A. 4 divided by 2, you have B. So you have AB squared. And then, we are left with the factors of 24, whose you can think of factors where one of the factors is the perfect square. So for 24, we can have 4 and 6. So 4 and 6. So you just write square root of 4. So you have square root of 4, that's 2ab squared. Then you just rewrite square root of 6. So the final answer here will be 2ab squared square root of 6. Next step or next case is indices are different but radicands are the same. So we're going to follow the steps on how to simplify this kind of case. Now, so number 1, transform the radicals to powers with fractional exponents. Number 2, multiply the powers by applying x raised to m times x raised to the n power is equal to x raised to m plus n. Rewrite the product as a single radical. Simplify the resulting radicand if necessary. Okay, so let's have our examples here. So number 1, you have the cube root of 5 times the square root of 5. So they have the same radicand but differ in index. So the first, let me go back. So transform the radicals to powers with fractional exponents. So from the cube root of 5, so this becomes 5 raised to 1/3 times 5 raised to 1/2. So this is cube root 1/3, square root is 1/2. Then the next step, multiply the powers by applying the laws of exponents. So since they have the same radicand, so we can rewrite 5. Then we have to add 1/3 plus 1/2. And then rewrite the product as a single radical. So we're going to add 1/3 and 1/2. Writing the LCD for this. So the LCD or the common denominator will be 6. 3 and 2 is the LCD is 6. And then you can just cross multiply 2 and 1 and 3 and 1. So 2 times 1 is 2. 3 times 1 is 3 over 6. So this becomes 5 raised to 5 over 6. So this is now one single radical. Then we can rewrite it back as a radical. So that becomes the 6th root of 5 raised to the 5th power. So we're going to raise 5 times. So that is 3,125. So that will be the sixth root of 3,125. So that is the final answer for number 1. Okay. Next, number 2. We have square root of 2 times the cube root of 2 times the fourth root of 2. So again, we're going to rewrite this radical into fractional exponents. So you have 2 square root of 2 is 1/2. 2 raised to 1/3. Then 2 raised to 1/4. And then we rewrite first 2 followed by 1/2 plus 1/3 plus 1/4. So the LCD here will be 12. Okay, 12. So 2 raised to 12. So we can multiply first the numerator, then divide by the denominator. So 12 times 1 divided by 2. So that is 6. Plus 12 times 1 divided by 3, which is 4. Then 12 times 1 divided by 4 is 3. So that is a single denominator. So we can add the numerator. So you have 2 raised to 6 plus 4, 10 plus 3 is 13 over 12. So we can rewrite it now as a single radical. So this becomes the 12th root of 2 raised to 13 power. Okay, so we're going to raise 2 13 times. Or we can simplify this part by taking 12 inside this radicand. Okay, since we have an index of 12 outside the radical sign, so instead of raising to 13 times, we can write it as the 12th root of 2 raised to the 12th power times 2. So it's just the same as 13, but here we can apply the law of radicals by cancelling the index and the exponent inside by dividing the index and the exponent, so that becomes 2, then the 12th root of 2. Okay, so this will be the simplified answer. Okay. Okay, so the next case is you have indices and radicands that are different. So we're going to follow these steps. Number 1, so we're going to transform the radicals to powers with fractional exponents. To change the fractional exponents into similar fractions. 3, rewrite the product as a single radical. Number 4, simplify the resulting radicand if necessary. Okay, so let us have our first example. So we have the square root of 2 times the cube root of 4. So we're going to convert first this radical to fractional exponent. So square root of 2 is 2 raised to 1/2 times 4 raised to 1/3. And then the next step is, since you have different radicand, we can express the fractional exponent as a single fraction, or they must have the same denominator. So you have 1/2 plus 1/3. So basically we're going to add 1/2 and 1/3. So finding the LCD of 2 and 3. So that will be 6. So that will be 6 times 1 divided by 2. That will be 3. So that is for, actually that is for 2 raised to 1/2. So from 1/2, this becomes 2 raised to 3 over 6 times 4, you have 6 times 1 divided by 3. So that will be 2 over 6. Okay, so actually there's no need for us to add the fraction. We just identify the fraction as a single fraction, or they must have the same denominator, similar fractions. Okay, so we're going to start here again. So you have 2 raised to 3 over 6 times 4 raised to 2 over 6. So they have now the same denominator, so we can return it again to radical, wherein they will share the same index. That will be the 6th root of 2 cubed times 4 squared. And then the next step is we just apply the exponent. So that is the 6th root of 2 cubed, that is 8, times 4 squared, which is 16. So 8 times 16, that will be the 6th root of 128. Then we think of factors of 128, where one of the factors is a perfect 6th root. Okay. So the only factors we have there, it will be the 6th root of factors of 128. You have 64 and 2. So the 6th root of 64 is a perfect 6th root. So the 6th root of 64 is actually 2. Then rewrite the 6th root of 2. So the final answer is 2, the 6th root of 2. Okay, so that is how we apply the process of simplifying radicals in multiplication, wherein they have different radicand and indices. So let us have number 2. So we have the 4th root of 2 times the square root of 3. So the first step again is to convert this into fractional exponents. So that is 2 raised to 1/4 multiplied by 3 raised to 1/3. So again, they have this different denominator. So we can write it. We can find first the LCD of 4 and 3. Or actually, it should be 1/2. This one is 1/2 because it is only the square root of 3. So this is 1/2. So again, so you have 2 raised to 1/4 times 3 raised to 1. Okay. So LCD, you can just allocate the LCD. Right here the LCD, which will be 4. So the LCD is 4. Okay? So the same thing, this is still 1/4, so that's 2 raised to 1/4 times, here you have 3 raised to 2/4. No? 2/4. And then, they have now the same denominator here, so we can write it as a single radical. So we have here the 4th root of 2 raised to 1 times 3 squared. So we have now the 4th root of 2 times 3 squared, which is 9. So 2 times 9, that will be equal to the 4th root of 18. So there are no other factors for 18 that has a perfect 4th root. So this will serve as our final answer. Okay, so that is how we multiply radicals whose indices and radicands are different. So in most cases, the case numbers 2 and 3 are quite similar, but you have to follow the steps in rewriting the product as a single radical and then simplifying the result if it is needed. Okay, so that's it. So that is how we multiply radicals, where these cases has to be considered. So thank you very much. I hope you learned something today, and have a good day.